Hello, in this lecture we'll find out the area of a circle using two different methods. In the drawing we have a circle and also square ABCD. This is 1/7 AP, that's equal to 1 unit in its length. This is 1/7 QC, that equals to 3 units. Again, our mission is to find out the area of this circle. So we start with the first method. First of all, ABCD is a square, and therefore all those 4 angles inside square ABCD are right angles. So this is a right angle. This is also a right angle. This is a right angle. And this is a right angle. In the next step, we'll define the center of this circle. This point is point O. And we define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we'll join points O and S together by a straight line. Point O is the center of the circle. Point S is a point on the circle itself. Therefore, OS is the radius of this circle. We define the radius of this circle as x. So OS equals to x. It is the radius of the circle. Here we can implement rule 1. So repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. In the drawing, we have a circle, and this is tangent AB. This is tangent to this circle at this point, point M. Point M is the point of tendency of tangent AB with this circle. In addition, we have the radius OM that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. So we can actually implement rule 1 in our drawing. In our drawing, we have the radius OS that is equal to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we'll join points O and Q together by a straight line. Point Q is the point of tendency of tangent BC with this circle. So OQ is the radius of this circle, that is equal to x according to our definition. We can implement rule 1 here because we have the radius OQ that is equal to x. The radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So by doing this construction, so we get the quadrilateral SOQB. Inside this quadrilateral SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the sides of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside this quadrilateral SOQB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must make this left angle flat as square. So we relate to this quadrilateral SOQB that has 4 right angles as a left angle. And we also know that the opposite sides of the left angle are equal to each other. So left angle SOQB, side SO must be equal to the opposite side QB, but SO is x, therefore QB must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle SUQB, side QO equals to the opposite side SB, but QO is x, therefore SB must be also equal to x units in its length. So if you found out that quadrilateral SOQB is not a rectangle but a square, why? Because of the fact that all of its sides are equal to each other, each side of this square is equal to x units in its length. Okay. So we know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA, and especially side AB equals to side BC. So I write it down. So in square ABCD, so side AB equals to side BC. AB in total equals to AS plus SB. AB equals to AS plus SB. And know that AB equals to BC, so BC in total equals to BQ plus QC. BC equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB equals to X. And AS plus SB equals to BQ plus QC. BQ is also X plus QC. QC equals to 3 units in its length according to what is given as the question. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. Here we subtract X from this equation, equation 1. So X will get cancelled. And we left only with AS, this is equal to 3 units in its length. So actually found out that the length of this missing line segment AS is equal to 3 units. So I'll write it down. AS equals to 3 units in its length. In the next step, we will do a construction, that is to say, from this point P, we will draw perpendicular on the radius SO. Again, from point P, we will draw perpendicular on the radius SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P inside SO. This point is point N. By doing this construction, we get the small quadrilateral APNS. Inside this small quadrilateral APNS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4 missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral APNS we have 4 right angles, And according to rule 5, any quadrilateral that has 4 right angles must be a test rectangle, not a square. So we relate to this small quadrilateral AP and S as rectangle because it has 4 right angles. So write it down. Quadrilateral AP and S is rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AP and S, side AP must be equal to the opposite side NS, but AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the sum rule, in the same rectangle AP and S, side AS must be equal to the opposite side NP, but AS is 3, therefore NP must be also equal to 4 units in its length. What is the length of this missing 97, NO? For the moment, it is very easy to see that NO in total equals to SO minus SN. Again, SO minus SN equals to NO. So write it down. NO equals to SO minus SN. So NO in total equals to SO. SO is the radius of this circle that is equal to X. Minus Sn equals to 1. So in total, NO equals to X minus 1 units in its length. This is nice to write NO that is equal to X minus 1 units in its length. In the next step, we join points P and O together by a straight line. Point P and point O is the center of the circle. Point P is the point of the circle itself. Therefore, PO is the radius of this circle. It is equal to X. In the next step, we'll copy this green right triangle P and O in a new page, and we'll implement the Pythagoras theorem on this green right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a abbreviation for Pythagoras theorem. So actually, this is the green right triangle P and O that I copied from the original drawing. According to the Pythagoras theorem, on this right triangle P and O, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. So I write it down. So PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. The hypotenuse PO equals to X units in its length, therefore PO squared is X squared, and it is equal to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus NO squared. NO is X minus 1, Therefore, n mod square is x minus 1 squared. So in total, according to the Pythagoras theorem, we derive by PMO, x squared equals to 9 equals x minus 1 squared. So x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2 times x times 1, that is minus 2x. So here we have x squared on both sides of the equation, so x squared will cancel. So on this side, after we cancel x squared, on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10, minus 2x. So in total, if we found out that 0 equals to 10 minus 2x. Here we add 2x to this equation, and we get that 2x equals to 10. So here we divide this equation by 2 and finally get that x equals to 10 over 2, that is 5. So we found out that the length of the hypotenuse PO, that is x, is equals to 5 units. X is also the radius of this circle. So we found out that the radius of this circle, x, equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle, is equal to pi times the radius of the circle squared. And again, the area of any circle is equal to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So the area of our circle equals to pi x squared. So it is pi times x squared. X is 5, therefore x squared is 5 squared. So the area of our circle equals to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54 square units. So if we found out that the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this circle according to the second method. So we know that ABCD is a square, therefore all those 4 angles inside square ABCD are right angles. So this is a right angle. This is also a right angle. This is a right angle. And finally, this is also a right angle. In the next step, we'll define the center of this circle. This point is point O, and we'll define the point of tendency of tangent AB. This tangent AB with this circle, this point as point S. In the next step, we'll focus on this common standpoint, point B. From this common standpoint, point B, we have 2 tangents to this circle, tangent BQ and tangent BS, and according to rule 2, they are equal to each other. So I click quickly on rule 2. According to rule 2, the lengths of 2 tangents from a common standpoint to a circle are equal. So in the drawing, we have a circle, and this is the common standpoint, point P. From this common standpoint, point P, we have 2 tangents to this circle, tangent BA and tangent BB. And according to this rule, all 2 they are equal to each other and their lengths. That is to say, PA equals to PB. So we can implement rule 2 in our drawing. So as I mentioned before, if we focus on this common standpoint, point B, we have 2 tangents to this circle, tangent BQ and tangent BS. And according to rule 2, they are equal to each other. That is to say, BQ equals to BS according to rule 2. So I write it down. BQ equals to BS according to rule 2. So if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other according to rule 2. In the next step, we'll extend side AD of this square ABCD by a straight line until it touches the circle. And we'll define the touching point of the extended line segment AD with this circle. This point is point M. In the next step, we'll focus on this common example point A. From this common example point A, we have tangent AS that is tangent to this circle at this point S. And from the same common example point A, if we draw a straight line here, it will cut the circle at 2 points P and M. So from the same common example point M, we have also chord PM. And therefore, we can implement here rule 10. According to rule 10 is true in any circle. So in any circle, if AB is any chord in the circle, AB is a chord in this circle, and PT is a tangent to the circle, PT is tangent to the circle at point C. Then in this drawing, the following equation is true. That PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule 10 in our drawing. In our drawing, as I already mentioned before, from this common example point A, we have tangent AS, and from the same common example point A, we have here chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, the following equation is true, that AS square equals to AP times AM. Again, AS square equals to AP times AM. So I write it now. But before that, before I write down rule 10, we'll calculate the length of tangent AS. In the first method, we found out that AS equals to 3 units in its length. We'll do the same calculation again. Here we have in square ABCD, all of its sides are equal to each other. That is to say, side AB equals to side BC. So in square ABCD, side AB equals to side BC. AB in total equals to AS plus SB. AB equals to AS plus SB. And AB equals to BC. BC in total equals to BQ plus QC. BC equals to BQ plus QC. So in total, according to equation 1, we found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we'll leave it as it is. AS plus SB. SB equals to X and it is equal to BQ. BQ also equals to X plus QC. QC equals to 3. So in total, according to equation 1, we found out that AS plus X equals to X plus 3. Here we subtract X from this equation and we get that AS will get X will get cancelled. So we're left with only AS that is equal to 3 units in its length. So found out that AS equals to 3 units in its length. Now return back to rule 10. Because of the fact that from this current standpoint point A we have tangent AS, and from the same current standpoint point A if we draw a straight line, it will cut the circle 2 points P and M. So we created here called PM. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, the following equation is true, that AS square equals to AP times AM. Again, AS square equals to AP times AM. So write it down. If we focus on the current standpoint point A, according to rule 10, the following equation is true. That AS square equals to AP times AM. AS is 3, therefore AS squared is 3 squared, this is 9. And it is equal to AP times AM. AP is 1. Times AM. AM in total equals to AP plus PM. AM equals to AP plus PM. So if we found out that according to rule 10, 9 equals to 1 times AP plus PM. Actually, any expression that is multiplied by 1 will not change its value. Therefore, we can ignore 1 in this equation. And we get that this equation equals to 9. And here we ignore 1. And we're left only with AP plus PM. If we found out that according to rule 10, 9 equals to AP plus PM. So 9 equals to AP is 1 plus PM. 9 equals to 1 plus PM according to rule 10. Here we subtract 1 from this equation, and we get that PM equals to 9 minus 1, that is 8. So if you found out that the length of this chord PM is equal to 8 units. In the next step, we'll do a construction, that is to say, from this point O, that is the center of this circle, we'll draw perpendicular on the chord PM. Again, from point O, we draw perpendicular on chord PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and this chord PM. This point is point N. So we actually draw perpendicular ON on chord PM. Again, we draw perpendicular ON, that is one from the center of this circle, that is to say point O, on chord PM. And for that reason, you can implement here rule 11. According to rule 11, whenever you draw a perpendicular that is drawn from the center of the circle on any chord, it will bisect the chord. Therefore, perpendicular ON, that is one from point O, that is the center of the circle, will bisect chord PM. So I pick quickly on rule 11. According to rule 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So in the moment we have a circle, this is point O, that is the center of this circle, this is chord AB. from point O, that is the center of the circle, we draw perpendicular OM on chord AB. Again, from point O, we draw perpendicular OM on chord AB. And according to this rule 11, whenever you draw a perpendicular that is drawn from the center of the circle towards any chord, it will bisect the chord. Therefore, perpendicular OM bisects chord AB. That is to say, perpendicular OM divides chord AB into two halves. Each half equals to AB over 2. So the first half is AM, and it is of course equals to the second half, that is MB, and each half equals to AB over 2. So AM equals, the first half is AM, and it is equals to the second half, that is MB, and each half equals to AB over 2. So we can definitely implement rule 11 in our drawing. Because in our drawing, from the center of this circle, that is to say from point O, we draw perpendicular ON on chord PM. Again, from point O, that is the center of the circle, we draw perpendicular ON on chord PM. And therefore, according to rule 11, perpendicular ON bisects chord PM. That is to say, perpendicular ON divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and it is equal to the second half, that is PM, and each half equals to PM over 2. So I write it down. According to rule 11, perpendicular ON that is drawn from the center of the circle, that is to say from point O, bisects chord PM. That is to say, divides chord PM into two halves. The first half is PN, and it is equals to the second half, that is NM, and each half equals to PM over 2. So according to rule 11, we have found out that PN equals to NM equals to PM over 2. PM is 8, therefore PM over 2 is 8 over 2, that is 4. So from this long equation, we will derive that Pn equals to 4. Okay, Pn equals to 4. That is to say, the length of this line segment Pn is equal to 4 units. So I write it down, Pn equals to 4. In the next step, we will join points O and S together by a straight line. Point O is the center of the circle, point S is the point of the circle itself, therefore OS is the radius of this circle. So I write it down, OS is the radius of this circle. Because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. By doing this construction, we can do quadrangle OSAN. Inside this quadrangle OSAN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees, and therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrangle OSAN, we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be tesseracted if not a square. So we relate to this quadrangle OSAN as a rectangle because it has 4 right angles. So this is quadrangle OSAN, and it is a rectangle according to rule 5. But we also know that opposite sides of a rectangle are equal to each other. So in rectangle OSAN, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5, therefore OS must be also equal to 5 units in its length. OS equals to 5, but OS is the radius of the circle, and therefore the radius of this circle equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle is equal to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, therefore the radius squared is 5 squared. In total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, and therefore in total this expression equals to 25 pi. 25 pi is 78.54 square units. So, in both methods, we found out that the area that we're looking for in this question, that is the area of this circle, it is equal to either 25 pi square units, or in terms of numbers, it is equal to 78.54 square units. So, in the next step, I'll summarize the lecture. We start with the first method. So, in this lecture, we found out the area of this circle using two different methods. So we start with the first method. In the drawing, we have a circle, and this is square ABCD. It is given us the question that this is line segment AP, that is equal to 1 unit in its length. This is line segment QC, that is equal to 4 units in its length. Again, our mission is to find out the area of this circle. So first of all, because of the fact that ABCD is a square, all those 4 angles inside square ABCD are right angles. In the next step, we define the center of this circle. This point is point O, and we define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we join points O and S together by a straight line. Point O is the center of the circle. Point S is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OS is the radius of this circle. We define the radius of this circle as x. So OS equals to x. So we can implement rule 1. Why? Because of the fact that the radius OS that is equal to x, the radius OS is 1 to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is 1 to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by a straight line. OQ is the radius of this circle, is equal to x. So the radius OQ is 1 to point Q, that is the point of tendency of tangent BC with this circle. And whenever your radius is 1 to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule, rule 1. By doing these constructions, we get a quadrilateral SOQB. Inside this quadrilateral SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 470 degrees. So 270 degrees plus the size of this 4 facing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4 facing angle must be equal to 90 degrees in its size. So inside quadrilateral SOQB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle in front of square. So we will relate to this quadrilateral SOQB is rectangle because it has 4 right angles. But we also know that the opposite sides of the rectangle are equal to each other. So in rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB must be also equal to x units in its length. Likewise, according to the sum rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ is x, therefore SB must be also equal to x units in its length. So if we found out that quadrilateral SOQB is not rectangle but a square, why? Because of the fact that all of its sides are equal to each other, each side of this square SOQB is equal to x units in its length. We know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC in square ABCD. So in square ABCD, side AB equals to side BC. AB is AS plus SB. Again, AB is AS plus SB, and it is equal to BC. BC is BQ plus QC. Again, BC is BQ plus QC. So in total, according to equation 1, we have found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus BS. BS is X, and it is equal to BQ. BQ is also X plus QC. QC is 3. So in total, according to equation 1, we have found out that AS plus X equals to X plus 3. Here, we subtract X from this equation 1, so X will get cancelled, and we left only with AS that is equal to 3 units in its name. This is 970 AS, it is equal to 3 units in its name. In the next step, we did the construction, that is to say, from this point P, we draw perpendicular on the radius SO. Again, from point P, we draw perpendicular on the radius SO. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P, and this side SO, this point is point N. By doing this construction, we created the small quadrilateral APNS. Inside this small quadrilateral APNS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its side. So inside the small quadrilateral APNS, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be its right angle plus a square. So we know to this quadrilateral APNS is a right angle. But we also know that the opposite sides of right angle are equal to each other. That is to say, in rectangle APNS, side AB must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the same rule, in the same rectangle APNS, side AS must be equal to the opposite side NP. But AS is 3, therefore NP must be also equal to 4 units in its length. What is the length of the missing line segment NO? NO equals to SO minus SN. Again, NO equals to SO minus SN. Okay, again, NO equals to SO minus SN. So NO equals to SO. SO is the radius of this second that is equal to X minus SN. SN equals to 1. So in total, NO equals to X minus 1. NO equals to X minus 1. In the next step, we join points P and O together by a straight line. PO is the radius of this second that is equal to X. In the next step, I copy this right triangle P and O in the new equation, we implemented the Pythagoras theorem on this right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Actually, this is the right triangle P and O that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle P and O, PO squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. PO squared equals to Pn squared plus NO squared. PO is X, therefore PO squared is X squared, and it is equal to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus NO squared. NO is X minus 1, therefore NO squared is X minus 1 squared. So in total, according to the Pythagoras theorem, in this triangle PNO, we found out that X squared equals to 9 plus X minus 1 squared. So X squared equals to 9 plus X minus 1 squared. X minus 1 squared equals to X squared plus 1 squared, that is 1, minus 2 times X times 1, that is minus 2X. So here we have X squared on both sides of the equation, so X squared will get cancelled. After we cancel X squared, on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10, minus 2X. So in total, we actually found out that 0 equals to 10 minus 2X. Here we added 2X to this equation, and finally found out that 2X equals to 10. Here we divided this equation by 2, and finally found out that X equals to 10 over 2, that is 5. So actually the length of the hypotenuse PO, that is X, is equals to 5 units. X is also the radius of this circle. So the radius of this circle is equal to X, that is equal to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. Therefore, in total, the area of our circle must be equal to pi x squared. So it is pi times x squared. X is 5, therefore x squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total, the value of this expression is 25 pi. 25 pi is 78.54. So if you follow that the area that we are looking for in this expression, that is the area of this circle, it is equal to either 25 pi square units, so in terms of numbers, it is equal to 78.54 square units. We finish with the first method. In the next step, I presented to you how to find out the area of this circle according to the second method. So first of all, because of the fact that ABCD is a square, all of its 4 angles are right angles. So all those 4 angles inside square ABCD are right angles. In the next step, we define the center of this circle. This point is point O. We define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we focus on this common external point, point B. From this common external point, point B, we have 2 tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. BS equals to BQ according to rule 2. So if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other according to rule 2. In square ABCD, all of its sides are equal to each other. That is to say, AB equals to BC equals to CD equals to DA, and especially AB equals to BC. Repeat again, in square ABCD, side AB equals to side BC. AB is AS plus SB. AB is AS plus SB, and it is equals to BC. BC in total is BQ plus QC. Again, BC is BQ plus QC. So in total, according to equation 1, we can find out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB is X, and it is equal to BQ. BQ is also X plus QC. QC is 3. So in total, according to equation 1, we can find out that AS plus X equals to X plus 3. Here we substituted S from this equation in equation 1. So X will get cancelled, and we left only with AS that is equal to 3 units in its length. This is line segment AS that is equal to 3 units in its length. In the next step, we extended side AD of this square by a straight line until it touches the circle. We find the touching point of the extended side AD with this circle. This point is point M. In the next step, we focus on this common external point, point A. From this common external point, point A, we have tangent AS. And from the same common external point, point A, if we draw this straight line, it will cut the circle at 2 points, point P and point M. In this way, we created a chord PM. So from the common external point, point A, we have tangent AS, and from the same common external point, point A, we have also chord PM. So all the requirements of Rule 10 are satisfied, and therefore we can implement the Rule 10. According to Rule 10, the following equation is true, that AS squared equals to AP times AM. Again, AS squared equals to AP times AM. So if we focus on the common external point, point A, according to Rule 10, the following equation is true, that AS squared equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9, and it is equal to AP. AP is 1 times AM. AM in total is AP plus PM. Again, AM in total is AP plus PM. AM is AP plus PM. So in total, we can find out that 9 equals to AP, that is 1 times AM, that is AP plus PM. Because of the fact that any expression that is multiplied by 1 will not change its value, we can ignore 1. So after we ignore 1, we get that this expression will be equal to 9 equals to AP plus PM. 9 equals to AP plus PM. AP is 1, so 9 equals to 1 plus PM. Here we subtract the 1 from this equation, so I found out that PM equals to 9 minus 1, that is 8. So the length of this chord PM is equal to 8 units. In the next step, we did the construction. That is to say, from this point O, that is the center of the circle, we draw perpendicular on chord PM. Again, from point O, that is the center of the circle, we draw perpendicular on chord PM. And we define the touching point of the perpendicular from point O and chord PM. This point is point N. Because of the fact that from the center of this circle, this point O, we draw perpendicular PN on chord PM, we can implement rule 11. According to rule 11, whenever you draw perpendicular from the center of the circle towards any chord, it will bisect the chord. That is to say, perpendicular ON bisects chord PM. If ON bisects chord PM, it means that it divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and the first half, of course, equals to the second half, that is NM, and each half equals to PM over 2. So according to rule 11, perpendicular ON bisects chord PM into two halves. The first half is PN, and it is equals to the second half, that is NM, and each half equals to PM over 2. PM is 8, therefore PM over 2 is 8 over 2, that is 4. From this long equation, we derive that PM equals to 4 units. This is to say, PN, this is nice about PN, that is equals to 4 units in its length. In the next step, we join points O and S together by side line. Point O is the center of the circle, point S is the point of the circle itself, therefore OS is the radius of this circle. Because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then according to rule 1, tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So by doing this construction, we created a quadrilateral ANOS. Inside this quadrilateral ANOS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral AP and inside quadrilateral ANOS, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle plus a square. So we relate to this quadrilateral ANOS as a right angle because it has 4 right angles. Okay, but we also know that the opposite sides of a right angle are equal to each other. So a right angle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5. Therefore OS must be also equal to 5 units in its length. The opposite side OS must be also equal to 5 units in its length. But OS is the radius of the circle. Therefore the radius of this circle is equal to 5 units. Our mission is to find out the area of this circle. Actually, the area of any circle, equals to pi times the radius of the circle squared. And therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5. The radius of our circle is 5, therefore the radius squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, and therefore in total, the value of this expression is 25 pi. 25 pi is 78.54. So in total, if you found out in both methods, that the area that you are looking for in this question, the area of this circle, it is equal to either 25 pi square units, so in terms of numbers, it is equal to 78.54 square units. Okay, thank you very much.